Hi everyone. Today we're going to study limits at infinity and horizontal asymptote. Let us study limits at infinity. If the values of f of x become arbitrarily close to L as x becomes sufficiently large, we say the function f has a limit at infinity and write limit of f of x as x approaches infinity equals capital L. Now, if the values of f of x becomes arbitrarily close to L for x less than 0, as absolute value of x becomes sufficiently large, we say that the function f has a limit at negative infinity and write limit of f of x as x approaches negative infinity equals capital L. If the values f of x are getting arbitrarily close to some finite value capital L as x approaches infinity or x approaches negative infinity, the graph of f approaches the line y equals capital L. In that case, the line y equals capital L is a horizontal asymptote of f. For example, consider the function f of x equals 2 plus 1 over x. Here is the graph. We can see here, as the values of x get larger, the values of f of x approach 2. We say the limit as x approaches infinity of f of x is 2 and write limit of f of x as x approaches infinity equals 2. Similarly, for x less than 0, as the values absolute value of x get larger, the values of f of x approaches 2. We say the limit as x approaches negative infinity of f of x is 2 and write limit of f of x as x approaches negative infinity equals 2. Now, the line y equals 2 is a horizontal asymptote of the function. Let's have now the formal definition of horizontal asymptote. If the limit of f of x as x approaches infinity equals capital L, or the limit of f of x as x approaches negative infinity equals capital L, we say that the line y equals capital L is a horizontal asymptote of f. Let us see this figure 1. We have the graph of f of x. As x approaches positive infinity, the values of f are getting arbitrarily close to capital L. The line y equals L is a horizontal asymptote of f. Let's have this figure 2. We have this graph of f of x. As x approaches negative infinity, the values of f are getting arbitrarily close to m. So the line y equals capital M is a horizontal asymptote of f. We shall have sample problems for calculating limits at infinity and horizontal asymptote on the next video. I hope you learned something from this video. See you again next time.